Hello class, in this video we cover section 1.1. Please take time to read my table note and the content in a guided note. The video focuses on answering the examples. So, section 1.1 talks about two reasoning processes, induction and deduction. Differentiate between the two processes is the key of learning this section. There's a trick to remember to differentiate between the two things. Induction goes from specific to general, so the number of examples is increasing. As you can see, induction and increasing, the two words, they share the same initials. Let's find an example for induction. Let's say sparrows have wings, robins have wings, silvertail flycatchers have wings, so all the birds have wings. The statement that I have just gave goes from specific to general. From a few birds cases to make a conclusion to all the birds. Deduction, on the other hand, goes from the general to specific, so the number of examples is decreasing. Deduction, decreasing, they share the same initials, DE. We can find an example for deductive reasoning. Let's say all the doctors are intelligent, and my father is a doctor, so my father is intelligent. That is an example of a deduction. Goes from all doctors to my father. Yeah, from all the cases to one example. In my table note, I also include characteristics for both reasoning processes. For induction, we want to know the conclusion, which is called a conjecture, is not certain. As you can see from the example I gave here, if we are finding other elements from a sequence based on the given first three elements, let's say the first three elements are 1, 2, 4, we can get two different sequences. The first one, if we see 1, 2, 4 as the powers of 2, 1 is 2 to the power of 0, 2 is 2 to the power of 1, 4 is 2 to the power of second. Then the next element would be 2 to the power of third, which is 8. Follow that, we should have 2 to the power of fourth, 16, and then 2 to the power of fifth, 32, and so on. Or we can see the first three elements as a arithmetic sequence. They have not arithmetic. We can see the difference between any two consecutive elements in the sequence. Between 1 and 2, we have the difference is 1. Between 2 and 4, the difference is 2. So we can derive then the difference between 4 and the next element would be 3. So that's how do we know the fourth element should be 7. And 7 plus 4 gives us 11. 11 plus 5 gives us 16, and so on. That's also a pattern. So as you can see, conclusion from a induction is not certain. That's a good example to explain the characteristic of inductive reasoning. We cannot, since the conclusion of induction is not certain, we could only evaluate the reasoning process as strong or weak. The conclusion can be proved as false by just one counter example. Let's look at this example in the table note. 3 is prime, 5 is prime, 7 is prime, so all odd numbers are prime. Can you find a counter example for that? This statement is false because we can easily find a counterexample to prove or disprove that statement. Yes, 3 is prime, 5 is prime, 7 is prime, but how about 9? 9 is odd number, but 9 is not a prime number. 9 is a composite. 9 has more than 2 factors. Besides 1 and 9, 9 is also divisible by 3. So induction, just remember, goes from specific to general. Induction goes from specific to general, is a bottom-up reasoning process. To know about deduction, the conclusion of deduction can be proved as true. If the conclusion is proved as true, then it is a theorem. It's a top-down reasoning process. We can evaluate a deduction as valid or sound. Yeah, that's something we will talk about in detail in later chapters. So as I said, the most important thing about this section is to know the difference between induction and deduction. Induction increasing, so it goes from specific to general. Deduction decreasing, goes from general to specific. Please pause the video and read those content, make sense of those content on your own. Let's look at examples. Find a counterexample to show that each of the statements is false. No singers appear in movies. This is a false statement because we should be able to find a singer who appears in a movie. Which singer? I'm not really good at knowing about musicians. How about Whitney Houston? She has a movie, right? Yeah, I remember that I watched that movie. Yeah, she's a singer, and then she appears in a movie. Next statement: if a number is added to itself, the sum is greater than the original number. How do we disprove this statement? By giving an counterexample. Let's try a negative number. Let's say -1. If we add -1 to itself, what is -1 plus -1? We have -2, right? -2. And -2 is smaller than original number. The original number is -1. Okay, when we compare two negative numbers, the one with bigger absolute value is actually smaller. Does that make sense? So this is a counterexample to disprove this statement. Next, we are going to apply inductive reasoning to identify a pattern in each list of numbers, then use this pattern to find the next number. All right, let's see. This is induction from specific to general, right? From the first 4 elements to find a pattern, and we can know other elements in the sequence. 1, 5, 25, 125. So if we see 1 as power of 5, yeah, we can see 1 as 5 to the power of 0. 5 is 5 to the power of first. 25 is 5 to the power of 2. 125 is 5 to the power of third. Do you see the pattern? So all the 4 elements in the sequence, the given 4 elements, are powers of 5. The base is 5. So we can derive the next element is gonna be 5 to the power of fourth, right? Yeah, you use your calculator to figure out what is the value of this number. 25 times 25. And the next sequence We are given 5 elements, 1, 4, 9, 16, 25. To answer this kind of questions, you need to have a good feelings about numbers. 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square. Yes, the given elements are perfect squares. Perfect squares. So then we know the next element is going to be 6 squared, which is 36, right? That's how we find the pattern and the rest elements in the sequence. The process is induction. Let's see, this sequence is a sequence of figures. As you can see, the first figure is a circle, followed with a square, and then followed with a circle, and then a square. So by the pattern, as you can see the pattern, the next figure should be a circle, right? It's alternating. Should be a circle. Okay. And now let's look at those dots. How those dots, what kind of pattern those dots are arranged in each figure. What I see is, if I look at this dot, and it's on the right, and now it's on the top, and then now it's on the left, right? And then it goes on the top, on the bottom. So as I can see, those dots are rotated counterclockwise for 45 degrees. By the way, you can pause the video anytime before I answer, before you watch my solution. You should give yourself a little bit of time to see if you can figure it out on your own. Same with here. Rotate 45 degree, goes to the right, and then 45 degree goes to the up, and then go to the left, and then it should go to the bottom, right? And this one is go to the here. And the 3 dots rotate counterclockwise 45 degree here, and on the right, on the top, and then it should be on the left, right? Yeah, it should be on the left. Left, bottom, right, top, left. So the next figure should be a circle with the dots like that. Okay. Examples for deduction. All proper names are prohibited in Scrabble. Texas is a proper name. Therefore, Texas is prohibited in Scrabble. It is deduction because the number of examples is decreasing from all names to Texas, the name of Texas. All people need to sleep at 7 a.m. You sign up for a class at 7 a.m. Therefore, you sleep through the lecture or not make it to class. From all to you, so that is also deduction. Let's practice deduction. This is to identify deduction or induction. Explain your answer. Number 1, the course policy states that work turned in late will be marked down a grade. I turned in my report a day late, so it was marked down from B to C. So induction or deduction? Pause and think. What is deduction? From all to you, right? Yeah, the policy applies to everybody, all the students in the class. And from that, by using the deductive reasoning, it also applies to you because you are one of the students in the class. So this is deduction. Number 2, an HMO does a follow-up study on 200 randomly selected patients given a flu shot. None of these people became seriously ill with the flu. The study concludes that all HMO patients be urged to get a flu shot in order to prevent a serious case of the flu. This conclusion is made for all the patients based on 200 selected patients. So this is what? Pause the video and think. The number of cases is increasing from specific to general. From 200 cases, make a conclusion about all the cases, right? This is induction. This is induction. Is the conclusion from the induction strong or weak in this specific case depends on if the sample, the 200 randomly selected patients, they are a sample, they make a sample, depends on if the sample representative or biased. So those are all the examples in section 1.1. You're ready. Now you're ready to work on your homework. I'll see you in next section. Thank you.